Hey guys, this is my second part for finding the derivatives of natural logarithms or ln. In the previous video, I went through basic kinds when you are given ln of something like 6x, 3x plus 1, so a linear argument. And if you are up to this video, I will link it down below in the description box, and you could definitely go ahead and check it out. Also, you need to know the chain rule, the basic idea of the chain rule, and I do have a bunch of separate videos on the chain rule. All of these links, I will link them down below in the description box, since chain rule I'm going to use in this video. Now, in this episode, I'm going to focus on these kinds where the argument of your ln function is going to be a square root, and you have some expression inside the square root. The next one, when your argument is a power, so some expression raised to the second power. Also, this case could be extended to any power, let's say third, fifth, or whatever power you are given. Next case, I'm going to have a look at something like reciprocal when you have like 1 over x or 2 over x. And finally, I'm going to cover when the argument of your ln function is ln function itself. I will take you through all of these cases and I will break them down one by one. Alright, here's the first example. Ln of square root of x minus 2. All you need to do is identify your outside function and your inside function. Basically, your outside function is going to be ln, natural logarithm, and you have something inside. So your inside function basically is square root, and inside of square root, technically, you are given another function. So it's x minus 2. So basically, your function, your original, your outer function, if it makes sense, is made of 3 functions. So again, you have ln as an outside function, first of all. Your inner, so this is your first function, outside, let's say. Inside function, you have this square root. And finally, inside the square root, you have x minus 2, which happens to be just a linear function. Alright, looks a little bit complicated, but is not that hard as it sounds. Let's break it down. Chain rule is your best friend for all of these problems. Chain rule basically says all you need to do is just take the derivative of outside function, which is again going to be ln of x, and recall that the derivative of ln of x or ln of u is going to be 1 over u, and since u potentially contains some expression in terms of x, again it could be any function in terms of x. So chain rule says that this one gets multiplied by the derivative of inside function, so the derivative of u. And if your u contains another function, like in our case, you have to apply the chain rule the second time, the third time. So double chain rule, triple chain rule, if it makes sense. So you keep going applying the chain rule as many times as you need. Let's do it. So first of all, the derivative of ln, again, it's 1 over. So I'm going to use this d over dx notation. You could use prime notation, whatever suits you best. So it's gonna be 1 over square root of x minus 2. So you have to take this entire argument. So basically, you could think of this as a kind of a substitution, and in reality, it is a substitution. So your u, you could match. Your u basically is going to be square root of x minus 2. And you have to also keep this inside in the function. So x minus 2. And we're not done yet, obviously. Times multiply by the derivative of inside function. So forget and ignore ln at this point. So take a look at what is your second inner function. It's going to be square root. And recall that the derivative of square root is 1 over 2 square root of x. And I do remember this as a separate rule. You could derive it every time, anytime when you hit into this from the power rule, and I do have a special videos, separate videos on the two derivatives you should memorize at square root of x and 1 over x, and I also will link them down below in the description box, and if you're up to this, go ahead and check it out. Anyway, so the derivative of this square root is gonna be 1 over 2 square roots, and again I'm going to write this x minus 2 inside. And finally, I'm going to repeat myself, since you have inside square root another function, which is x minus 2. Technically, you have to use the chain rule. However, look at x minus 2. The derivative of x minus 2 is going to be just 1, since the derivative of negative 2 is just 0, and the derivative of x is just 1. So basically, this 1, so you have to multiply by 1. This one does not affect your entire derivative, but it's the good policy to use the chain rule, to think of this as you have to apply it basically the second time. So again, you could ignore this one at this point, and all you need to do is just clean it up. So 1 still remains on top of your fraction, 2 I'm going to pull out front as a coefficient, and you have square root of x minus 2 times square root of x minus 2. You have the same expression inside of square root symbol, radical symbol. So basically, square root gonna disappear. It goes away, since basically you have square root of something squared. So basically, recall that squaring and taking the square root, the reverse operations of each other, so they entangle each other. So square root eventually goes away, disappeared, and you are left getting just x minus 2. So that's gonna be your final derivative for this function, and if you want, you could distribute it, open up the parentheses, expand it, taking these 2 and distributing over 2 terms inside, so it's going to be 2x minus 4. So if you would like to do this, go ahead and feel free, but for me it's fine, and I'm going to leave my answer like this. So that's your derivative for that function. Here's another one, ln of 3x minus 1 squared raised to the second power. The derivative, I'm going to use y prime notation, equals. So your outside function, again, is going to be ln. So the derivative of ln is 1 over. So 1 over, and this entire argument, so namely 3x minus 1, goes on the bottom of this fraction. And of course, we are not done yet. Life is not that easy, unfortunately. So this term gets multiplied by the derivative of inside. Look at this function. First of all, as I mentioned before, ln is your outer function. What you have inside? You have this power, second power, and you have linear function. Again, technically, generally speaking, your function is made up of 3 functions. It's ln, first of all. Second, you have power, and you have something inside your power, which is going to be a linear expression, 3x minus 1. Now, we need to take care of the derivative of the power. So remember that when we take the derivative of power, so we want to bring this power out front as a coefficient, and we want to reduce the power by 1. So 2 minus 1 becomes first power, and you have to keep this inside expression as is. It's gonna be 3x minus 1. And again, we are not done yet. We have to take care of the derivative of this inside function. So double, that's the moment where double chain rule kicks in, if it makes sense. So the derivative of 3x minus 1 is gonna be just 3. Since the derivative of x is just 1, x goes away, derivative of negative 1 is 0, just the constant. And technically we are done with the derivative. Again, I'm using and applying the chain rule twice, double chain rule. Now all you need to do is just clean it up, and 3 times 2 gives you 6. I'm going to place it on top, and look, 3x minus 1 you have to the first power, and you have the same term on the bottom of your fraction raised to the second power. So 3x minus 1 cancels this 3x minus 1. So you are left with, again, 6 goes on top, and 3x minus 1 remains on bottom. So that's gonna be your derivative for that one. Now moving on, say you have to handle this one, y equals ln of 2 over x. Precisely the same idea applies over there. So the derivative y prime equals 1 over this entire argument. Again, since you are given ln, your outside function, so you need to take care of the derivative of ln first. So it's going to be 1 over 2 over x, and since 2 over x, it's a fraction itself, and 1 over another fraction simply means you have to take this reciprocal, so you have to turn over, you have to swap top and bottom, so it becomes just x over 2, if it makes sense. And again, we are not done yet, so you are given 2 over x, your inside function. So we have to differentiate this inside function. And 2 over x could be thought as just 2 times 1 over x. This coefficient, this number on top, 2 over x, could be kind of pull out, if it makes sense. And all you do is just take the derivative of the rest, which is 1 over x. And the derivative of 1 over x is going to be negative 1 over x squared. I do remember this rule as a separate one. Many people tend to do the same. If you do not belong to these people, go ahead and derive it from the standard power rule by rewriting 1 over x as x to the negative 1 and applying the power rule to this point. Anyway, you will end up getting negative 1 over x squared. So this term gets multiplied. Remember, we still have these 2, and the derivative of 1 over x, it's gonna be negative 1 over x squared. And technically we are done. It requires just simplification. Since we want to clean it up a little bit, it becomes 2 and 2 cancel each other out, it goes away. You want to pull out this negative in front, so your term, your function becomes overall negative. So it has this negative in front. And basically, look, you have 1x on top and you have x squared on bottom. So x and this x cancel each other out. X goes away. You end up getting just 1 on top of your fraction and just 1x on bottom. And again, do not forget this negative sign, which comes out in front, and negative 1 over x, that's going to be the final derivative for this one. Alright, what if your inside function is made of ln of x itself? So looks a little bit peculiar. And to be perfectly honest with you, I'm giving this example to you on purpose in order to highlight and emphasize that your inside function could be something different from algebraic function, what we did before. Before it was just algebraic, it was linear expression, it was root, it was power, it was reciprocal. It could be something completely different. It could be transcendental function like ln of x or sine of x or tangent or e to the x or something like this. Don't worry, I'm going to take you through this. First of all, again, ln of x is your outer function, so take the derivative of outside. So y prime equals, and it's going to be 1 over, ask yourself, what is your inner function, what is your inside function? Your inside function, you could simply ignore ln at this point, this outside ln. So your inside function is ln itself, so write it in place of this argument ln. Now, we're not done yet. Yes, we're not done yet. We have to take care of the derivative inside function, which is ln of x. So, the derivative of ln of x, again, 1 over x. So, this term gets multiplied by 1 over x. So, we differentiated this inside function. So, inside function, again, which is ln of x, differentiated at this point. And we're done. Yes, we're done. There is nothing else inside, it's just ln of x. We did apply the chain rule again at this point, and all you need to do is just simplify. There is nothing much you could do about this, since you have one x variable, algebraic function, if you will, and you have this ln of x. The proper way of writing your result, just keep it short and sweet. Just by writing it as a one single fraction, since basically technically you are given two fractions being multiplied. We call that multiplying fractions, and all you do is just multiplying top straight across and multiplying bottom straight across. Since you have ones on top, so 1 becomes overall 1. And technically, typically, we place this x in front. X comes in front of your ln of x, in front of all your transcendental functions. So it's going to be x times ln of x. And normally, we neglect this multiplication between. So that's going to be your neat, compact, more beautiful, short and sweet, if it makes sense, a result for that function. Alright, so I hope you found it helpful to you. Huge thanks for watching and training your brain. I know everyone hates maths, but if you like my video, please hit this like, share with your friends, leave the comments down below, and make sure to smash that subscribe button if you haven't, and turn on this notification bell so you will not miss out my new uploads. To recall the recall